Hi everyone, my name is Yulia and this is CS50 Week 4 Sections, and today we're talking about all things memory. I am a preceptor here on Harvard campus and it is very lovely to see you all here in the room. So today we're talking all things memory, and that includes pointers, file IO. We're going to get some practice with how to operate these weird pointers things, and also some practice with how to open files, write into them, and read information from them. That should really help you on this week's problem set. So let's jump right ahead and let's talk about pointers first. So you might recall from week 1, we talked about a phone book, right? We set it up with different variables, such as calls that we try to keep track of for example, how many times your mom or your friend called you. So let's just get a quick refresher on that. So as in week 1, we had our variable called int calls that is of type int, and that stores value 4, for example. And you can visualize it as this sort of box, right? We're going back to our boxes. We're visualizing these diagrams again. So for example, our value was 4. Well, recall now that every variable also has an address, and here we came up with a fake one, and it will certainly look different in your system, but every variable has an address, and so using this address, we can now create a pointer. And so what are these pointer things? Well, the setup is again very similar, where we have a name of our variable, which is p, sort of like short for pointer, but again, it can be anything you want. The type is a pointer to an integer, right? And the way that we define that is by having int come very first to define this data type that our variable is going to point to, and the asterisk right next to p is what makes this variable a pointer. And what do these pointers store? Well, they store addresses, right? You can now imagine this second box that now stores an address of variable calls. Note too that since every variable has an address, variable p will also have an address, although we rarely use them, and it is just important to emphasize that it exists out there. So just to reiterate again, what happened here is we had variable calls that's storing a value of 4. We then created another variable, and you can imagine it by visualizing a second box right next to it that is now pointing to our previous variable, but it's storing essentially the address. And so let's go back again one by one, actually defining what each of the values are. So the value of calls is 4, right? That's what we had before. That's what we learned during week 1. It is int calls equal 4. Therefore, the value is 4. The value of p is in turn the address of calls, right? Pointers store addresses of the variables they point to. The address of calls is again this hexadecimal value that we have under our box, and we can access it using the ampersand symbol. In turn, p, our pointer, also has its own address, right? And although we might not be using it as much throughout the class and like in general, but every variable still has an address, and it's important to mention that. Well, how do p and calls combine? Using star p, you're essentially telling your computer to go to the value at the address stored in p. And so this is where our two boxes come back together, right? On the left-hand side, you have your p variable that is storing the address of calls. Calls in itself is its own variable that's storing value of 4 and has an address of 0x1a. And when we use asterisk p or star p, what is going on is this arrow situation, right? Like we're grabbing the value from calls by referencing this variable. And let's go over some of the syntax, right? Like some of these operators that I've been using. So type star is a pointer that stores the address of a type, right? So today we'll be using get a lot of int star, but it can also be char star, right? Which is where this week we sort of like uncovered what's been sort of hiding from you. And recall that in the previous weeks I said, well, strings actually don't exist, sort of, right? And char star is actually the correct way of defining it. Asterisk x takes that pointer, takes a pointer of x and goes to the address that's, sorry, star x takes a pointer x and goes to the address stored in that pointer, right? So as, for example, here we had p that was storing the address of calls. And then knowing this address, it can find where the calls variable is located very easily, right? It knows exactly what cell to go to, and then it can access the value located there. And lastly, we have ampersand x that takes x and gets its address. So that was important when we're defining our pointers in the very beginning, right? Like we want to make sure we're grabbing that address from the variable that we're interested in so that we can store it in the pointer afterwards. Okay, and I know this week has been like another fire hose of information, a lot of new symbols, like visualizing memory now becoming more difficult, right? Because it becomes this like more abstract thing. And hopefully through the next exercise and as you're working through these problems on your own, you can get a better grasp of what's going on. And again, it would be really helpful to visualize it on paper or the whiteboard, right? Like drawing it out and really connecting the cells and the arrows together. But before we jump to our next exercise, what questions do we have so far about pointers? I'm gonna look at the chat here. Someone said, is the variable name stored somewhere or it's just the value? So you can imagine it's like a box that stores the value, but then the way that we access the box is using the variable name that we defined. Let's see. What's the danger of using pointers? I think here again we're entering this like land of memory, right? Like it is becoming a little bit more abstract and it is like almost like a less controlled environment. So like with the pointers and with malloc that Professor Malan introduced this week as well, we are more prone to, for example, segmentation faults, right? Or like memory leaks and those kind of errors. But in turn, pointers really empower us to do more complicated things that we could not have done before. And as we'll see in the end of this section, one of those things is like accessing the files and working with them. So someone asked what exactly are memory leaks. It's a great question. It's essentially when you access something that you're not supposed to, or when you forgot to free the memory that you used or close the file that you used. And if it not, it doesn't necessarily come up with you running the wrong once or twice. If you don't follow exactly the steps, for example, allocating the memory, but also giving it back to the computer afterwards, you might run into these kind of issues. All right, let's keep moving for the sake of time, but our next activity is really getting practice with pointers and understanding how to correspond these things all together. So let's consider this variable x that we're setting equal to 4. And so as before, we can visualize it, right? We're creating this new box that has value 4 and some address. For the sake of the exercise, I came up with a fake one, but it'll certainly look different when you're trying to print out addresses in your computer. Next, let's create a pointer, right? So as before, the way that we define it is using int star p equals address of x. And as before, you can visualize this box, right, that stores the address of x. Notice how the two values correlate. Next, let's print out something, right? So this is where this magical connection comes in. So as I said before, when we use star p, that means that we're grabbing the address that is stored in our pointer and then accessing the value stored in that address. And so consequently, what we'll see in the terminal is And you can type in the chat if I'm printing out printf, quote unquote, %i, comma star p. Yes, so in our terminal we will see 4 because as I just said, what is happening is we're grabbing that address, we're going to the location of that address and grabbing the value stored in that cell. Okay, so this was, sort of like an exercise that we could have done with the previous slides, but let's push it a little further. So consider I want to change my value. So one way to do it is certainly just changing the value of x, but now that I have my pointers, I could also do it in this way. By using star p and setting it to 2, what is going to happen is I'm going to change the value of x. And now it is going to be equal to 2. Because as before, right, was the line 3, when we printed out the value, we used star p to grab that value. In the same way, we can access that value once again and change it, okay? So now our x is equal to 2. That is the value that's stored there. Now, if we wanted to print f star p minus 2, what would that be? What is the value that we're going to see in the terminal now? Exactly, it will be 0, right? Because the new value that I have in x is 2. I am subtracting 2, so I'm printing out 0 in the terminal. But will that change my value of x? Like, am I subtracting x minus 2 and now the value of x is 0 as well? Right, so some in the chat said no. I'm not explicitly changing x or even star p. I'm just printing that value out. Okay, so let's keep moving. And what we're going to print out last is x, right? So now that we've changed that value to 2, what we're going to see in the terminal exactly is 2. So using these pointers and the connection that we have between the addresses, we can now manipulate things even better. So, right, I don't have to like explicitly change values in my variables. I can reference them using pointers and then access that information through the addresses that connect the two, okay? So before we jump to file IO and switch gears a little bit, what questions do we have about this exercise and pointers? Yeah, so someone asked to explain the code. So let's walk through it line by line again. So in the very beginning, we have int x equals 4, right? That is creating this new variable. Then we need to set up our pointer, right? And as we just talked about, pointers to our addresses. So using the ampersand, we're grabbing that address of x, right? Like we're grabbing this hex value that is like signifying the address of x. Then our printf line, right? Like we've seen it a dozen of times so far. And to achieve the same result, I could have just said printf %i x, but I'm using the power of pointers to just reference that value and print it out here on line 3. Again, harnessing like the power of pointers and being able to reference the values without explicitly changing them. Well, in this case we are, but on the fourth line, right, where we're using star p equals 2 is where we're changing the value of x, and now it is 2. And then again, on those last two printf lines, we are just printing out different things, right, just for practice to see what we'll actually see in the terminal combined to what actually is stored in those variable cells. So let me go back to the chat again and see if there are any questions there. So someone asked, does changing the value of the pointer change the value of the variable permanently? So in this case, yes, right? Because we went explicitly to the location of this variable and we changed the value to 2. For example, on line, 5, when we printed out star p minus 2, we just use that value, right, and subtract it 2. Okay. So why didn't the last value change from 0 to 2? So on line 5, right, where we printing out star p minus 2, we're not explicitly changing the value of x, right? We are just using that value by referencing the pointer and subtracting 2 from it. Okay, let's keep moving forward for the sake of time, but I'll try to get some of my questions in the end of the section. File.io, right? So this is where why we need pointers comes in, right? So the things I just talked about, you could try to do that with just the variables that we knew, but with the files, this is where the pointers come really in handy, and this is what will enable us to do more complicated things that frankly we could do before. So to get us started, here are 2 of the key functions that we will use in the beginning. So the first one is fopen. This will allow us to open a file to either read or write into it. As I mentioned briefly just a few minutes ago, it is really important to close those files, right? So if we fopen anything like a file called input or a file called output, we must close it after we're done with it. So this is a really good practice to get into. Anything you fopen, make sure you close it, because again, we're going to run into these memory issues and weird errors that might be difficult to solve. So making sure that you have this very explicit approach of how you handle the code is very important. Okay. Yeah, someone's mentioning malloc in the chat. So this is again where all these errors come in. So we're not going to talk about malloc function a lot during this section, but malloc can be used to create memory, right? Like if we want to allocate some memory for us to use, but it's really important to free that memory that you allocated and use to go back to the computer so that we don't run into any memory errors. So let's consider this file. So for example, I have a txt file that has hi in it, and it is stored at some address. Well, how could I use it, right? Like how can I open it? How can I read from it or write into it? I can use my function called fopen. And again, it's whoa, things escalated really quickly, right? There was so much stuff going on, the stars, the capitalization, all the other arguments. So let's parse it one by one. So the first thing that we have is the name of the variable, right? Again, variable names can be anything that you want. So in this case, I chose input, but it could also be file or text or word, right? It is up to you as a programmer what variable names you want to use. Then with every variable definition comes the type, right? So in this case, our type is a pointer to file, right? So we've seen int star, we've seen char star. File star is again very similar, but someone just went ahead and defined what file is, and is literally these txt files or any other files, right? And so as before, our pointers store the address, right? So on the bottom of my txt file right here, I have its address. So what the input is actually going to store is the address of this file. And the way I could get that address is by using the fopen function, right? So when I use fopen, what it will return is the address of the file that I am trying to access. Well, let's parse fopen one by one as well. First argument is the file name, right? So hi txt or test PDF, right? It can be whatever file you want to use. Then the next argument is the mode, right? So in this case, what we want to do is just read from the file that we've opened. So we're using R, short for read. If we want to modify the file, right, or write something into it, the mode we can use is W. And I believe in this week's lecture, Professor Malan also defined something that like RB and WB, that is for reading or writing binary files, right? Explicitly saying that the sort of like the bits of the pieces of data that you'll be reading are binary, so like no need to try to like interpret it or understand what it is, right? So we have this setup. We've opened our file. We now have the address of our txt. What is going on next? Well, as before, there's an arrow, right? So again, we're going back to these diagrams and we're drawing things, but essentially what the input does, it is a pointer to the address where this txt file is stored. So you can imagine, again, the arrow that points to it. Okay? Now that we've opened our file, what can we do with it? So two key functions that we will talk about today and this week in general is fread, that will read data from a file, fwrite, that will write data from a buffer to a file. And what is a buffer? And we're going to talk about in just a second, but you can imagine it is just a chunk of memory that can temporarily store some data from the file. And there's a little hint of the question I'm going to ask you in just in 2 minutes. So you might think about it already, but why do we need the buffer, right? Like, why do we want to use it? So let's go back to our setup. We have this txt file that is storing hi, right, or any other text. What it actually is just collection of some pieces of data, right? So like collection of some bytes. So how do we actually read from it? There's a in this case, this is what we're going to do, but there's a very like methodic approach of how you want to read your data. Let's start from the end. So the very last argument in our fread function is location to read from. So this is the new file that you open, like the file where you want to grab the information from and, read it from there. So you can imagine it almost like a little dot or like a cursor that's showing you where this file is. Then next two parts is the size of blocks to read in bytes, and the in bytes part is important, right? Because in this case, I'm just reading size of 1 byte, but if you want to read something different, for example, if it is more than 1 byte and like maybe you don't know exactly like, oh, like is that variable like 2 bytes or 3 bytes, a handy function to use is size of. Because also depending on what machine you're using, for example, integer can be actually different size depending on the machine, and by using the size of function, you can always get the precise number. Next component of our fread function is how many blocks we want to read, right? So in this case, I want to read 4 blocks of 1 byte, right? So 4 blocks on 1 byte, and you can once again visualize it by sort of like allocating or highlighting these 4 squares in our text file. And lastly is the location to store blocks in, right? So in this case, it is buffer, and we're going to grab these 4 bytes from our input file, right, from hi.txt, and then store it in the buffer variable. And because I know that I'm going to read 4 blocks of size of 1 byte, I can pre-allocate that memory and have my buffer be ready to accept those bytes. So once again, this is the fread function that we'll use in this case, and to have sort of like an algorithm to it, this is how you can visualize it, right? So if we have fread, our function, the first argument will be stored to where, right? Into buffer, or whatever other variable name you come up with. Again, this is arbitrary. How many blocks and on what size? So 4 blocks of size 1, and here I'm flipping it a little bit, right, from what we saw before. But it is essentially size of 1 byte 4 times almost. And then from where, right? From the input file, or again, whatever name you chose to give to your input file. So again, to where, how many and on what size, and then from where. This is how we put our fread function together, and this is how we can visualize it in the end, right? We had our pointer input to the file that we were interested in. We grabbed 4 bytes from there, and then we stored it into buffer. So now input is pointing to the next bytes in our txt file. Okay. So this was reading information. How do we, okay, that was reading information, but why were we using buffer in the first place, right? Like I promised you to come back to that question, and now we're back to it. Why were we using buffer in the first place, right? Like why could I not have just done like fread from input to output and be done with it? Why it is important to use buffer? Why do we want to use buffer in this case? If anyone want to type their suggestions or thoughts. Okay, yeah, so just store it, yeah. We want to like store something in buffer. Temporary storage of data, okay. Memory, right, is a big consideration. There's one more thing. Yeah, someone said it's like a third glass from the lecture, so it's like our temporary variable that we're creating. So often we don't know where the data ends, right? So I can say like read 200 bytes, right? What if there are more bytes? Or what if there are not as many bytes? And by ensuring that we're doing just like little bits at a time, right? Maybe like 4 bytes at a time, even 1 byte at a time until we reach the end is why buffer is important, right? Like we're using this like third glass, as we talked about in like when we're swapping variables, like we're using this like third glass, third variable to be a temporary storage as we're sort of like moving things alone. Okay? So that's why buffer is important. That's why you will find using, you'll find still using buffer a lot this coming week to sort of like temporarily store information. But now that we've learned how to fread, let's talk about fwrite, right? So we not only just want to open information, we also want to make sure we know how to modify it. So the syntax is again very similar, but just slightly different. And let's go through it one by one. So with fwrite, the first argument that I have is from where, right? So contrary to fread, we're sort of like flipping things here. So first, from where, I want to write from buffer. Again, how many and what size? Well, in this case, 4 blocks of size 1. And then the last bit is to where, right? To my output file, or once again, whatever variable you choose to have. So flipping things a little bit compared to fread, but still the same idea, right? I want to read from buffer. I want to write from buffer 4 blocks of size 1, and I want to store them or write them into the output file. Okay, and so this is how we can visualize it again. So if I have these 4 bytes storing in my buffer, what fwrite would do is just copy them over to output, right? So now my output file has those bytes. Okay. So let's take a pause here. I'm going to spend some time answering questions before we go to the last activity of the day. What questions do we have about fread or fwrite, or how we were handling these pieces? Yeah, so someone asked to explain exactly what the blocks are. So if you open like a PDF file, right, or like a text file, you see text on the page, right? That is what's visible to the humans. But what is going on behind is like some sequence of like bytes, right? So this is how we like sort of handle these documents on like a micro level. We like go a level further and we say, okay, I want to read 1 byte at a time. It might be like, I don't know, a character, or just like if we're looking at the image, like it'll be something different, right? But it'll be 1 byte at a time. And again, by splitting the problem in these like smaller pieces, we can ensure that we're actually like getting through the entire file versus just like, let's read 200 bytes, right? Like maybe that's too much, maybe that's not enough. We want to make sure we're handling it bitwise. Okay, let's see. Yeah, so someone said fread is like copying some bytes from another file and transferring it to another file. Exactly. By using fread, I'm not changing my hi.txt, right? It is staying the same. Like I'm not taking things away. I'm just copying it or like referencing that file to read things into buffer. So if I go back a little back on my slides, right? So I moved my arrow 4 blocks forward, but they didn't necessarily disappear, right? Like those 4 blocks are still contained in my txt file. It's just for the purposes of this program, like I am moving forward, right? Like I've read those 4 bytes, so I can go on to read the next ones. Okay. Okay, so someone asked to see the F right side again, and I can go back to that. Okay, it's right here. So, right, this is F right syntax. But let's go ahead and get some practice with these guys, right? So like F read, F write, and working with the files. So on the menu today is the activity. So on the menu today is the activity that will allow us to detect PDF files, right? So what we're going to do is we're going to create a program called pdf.c. And again, you're welcome to follow along with me or reference it after this. But we will write a program that will read the file, and then we'll try to understand if it's a PDF or not. A helpful hint here is that all PDFs begin with a specific 4-byte sequence. And if you do some math and manipulation, you're welcome to figure out what exactly that is. But the example usage of the program is that when we run this PDF program and we plug in a specific file name, it should a specific file, it should let us know if it's a PDF or not, okay? So let's move to CS50.dev. And I already started it a little bit. Oh, okay. I need to go to my directory first. All right. All right, here it is. So I already pre-wrote some code just to help myself move along. So let's walk through it together line by line of all the to-dos that we need to do. So first, and I gave a little hint here. Okay, let's leave this here, but I will show why it is important. So first thing we're going to do is check usage, right? Like we're again making sure that we are writing our programs in a very defensive way. We are telling users exactly how many how many CLAs we're expecting from them and exactly what we want to see. Next, we're going to open that file that the user gave us. We're going to create buffer for that file, right? So again, we want to store just a little bit of it. We're going to create an array of signature bytes, right? So the signature byte is exactly the 4-byte signature or sequence that we're looking for in our PDFs. We're going to match them up, right? So looking at the first 4 bytes of our file, and then at the 4 signature bytes that we define in our array, we're going to compare them. And then if they all match up, then it is indeed a PDF. And if not, it's not a PDF file. And in the end, a very important thing we're going to do is we're going to close the file, right? Because we opened it in the very beginning and we want to make sure that we close it back again. Okay, so let's get started. And I'm going to again skip this comment just a second to show what happens if you don't check for CLAs. But let's start writing some code. So as we just saw in the slides, the way that we open file, the way we can use files, right, is by using the pointers. So the type that we're going to point to is file. This asterisk is what gives us a pointer, and I'm going to call my file input. I'm going to use fopen, and inside of fopen, I'm going to use my command line arguments to access the file name, right? So per usage right here, what we want to see from the user is ./pdf to run the program, but then the file name, which will be our second command line argument. And I'm opening it in mode read, right? Because I don't want to modify anything in it. I just want to make sure I'm grabbing the information that I need, and that is it. Okay? Next, I'm going to create buffer for that file, right? For the little bits of information that I'm going to read. And so I'm going to introduce something new, and it is uint8_t buffer. Okay, so the tricky thing in this whole line is just this guy, right? Buffer is just the variable name that I picked. For it is just defining that we will have 4 little cells in our array. But what is uint8_t? Does anyone know what that is? And it's okay if you don't. But yeah, so very close. Someone in the chat says, I believe it's a byte. Very close. It is a size of byte, but it actually is an unsigned integer, right? So first of all, it is making sure that we only have non-negative values, but it's also making sure that it's exactly 1 byte. As I mentioned before, depending on what machine you're using, integers can actually be bigger or smaller, but by using uint8_t, we're always ensuring that it is of size byte, right? Okay, now let's create another array where we're going to store our signature bytes. So this is what is going to help us identify if it is a PDF. And I have the signature bytes pre-written, so I'm just going to copy them over. Okay. So this will help us identify if it's a PDF, right? So it is just the 4 bytes that are always contained in the beginning of each PDF. And so by comparing what we will actually read from the file, we will be able to identify that. Okay. So this is where the tricky part comes in, right? Like all of these things, like we sort of knew like how to define arrays. fopen was a little bit new to us, but now is the interesting part, right? Like we want to read first 4 bytes from the file. And by looking at this keyword right here, I see that I'll probably use fread, right? And I mentioned in the beginning that we don't want to modify anything, but can you all help me out? So what 4 arguments do I want to put inside of my fread function? What was the structure of our arguments inside of fread? Okay, so I want to read to buffer. That is my first part. Then I already also have a hint to myself from the comments, read first 4 bytes. So I remember that my second argument in fread is the size, right? So I can say 1 because I know that uint8 is always 1 byte, right? Or I could be more diligent and use the size of function that I was telling you about. So by using size of, I can ensure that no matter what machine I'm using, I always get the exact size of this variable of this type. Okay, and then after the to location and the size comes the number of blocks, right? So I want to read 4 of those. And then where am I reading them from? What is the last argument? Okay. Some people already tapped in the chat. Yeah, it's input. Exactly. So I'm going to read it from input. Okay, let's make sure it compiles before we go any further. So make PDF, and this is where I'm going to show you why CLA is that important, right? So for example, if I try to do, I get this error, right? Segmentation fault. Why is that the case? Like, why did I get an error? Okay, so someone is saying F close. No. Yeah, so I need a value for RGB1, right? I didn't pass anything in. I only have ./PDF, but I don't actually have the file name. So when my computer gladly does what I told him to do, it gets to line 10 and it tries to open the file, but I never told him what that file was, right? I never gave it in the command line argument. So it is really important to make sure you're error checking your program correctly and that you're being a defensive programmer, right? Like you're telling your user exactly what you expect from them. So to write my if statement, how many, what should be my value of RGC? Like how many arguments am I expecting? What condition can I set here? 2, okay, so I can say something like, if RGC does not equal to 2, right, if they provided me with too many arguments or not enough, I want to give them a message. Please provide only one file name, right? And I want to quit. So I don't want to be going further because once again, I hit this line 14 now. My computer will try to open the file, but it can't because I never told him what this file was. All right. So let's compile this to make sure we update it. And let's run it again. And now I don't get any segmentation fault errors. And it is instead just telling me that I need to provide file name. Okay. All right, so we have read some bytes, and now let's check them, right? So essentially what I will have is the buffer array with 4 bytes of some information from my file, right? I also have my signature array of the bytes that I want to cross-check. How would I go about it, right? Like I want to compare these 4 bytes. Could I write something like if buffer equals to signature, then everything went well? Is that something that I could do? Okay, so yeah, people are suggesting to use a loop, and that is exactly the intuition behind it, right? I want to go comparing 1 byte at a time. So as we've seen these past weeks, we're going to set up a very simple for loop where I'm going to go until 4 because I'm only looking at the first 4 bytes. And inside my for loop, I'm just going to compare the values in each of the array 1 by 1. So I could do signature I, right, like indexing into the spot that I'm interested in. If it is not equal to the bytes that I have in buffer, what do I want to do? And I messed up the syntax here. Okay, so if I'm looking at the first value in the signature array, and I'm comparing to the first value in the buffer array, if they don't match up, what do I want to do? Exactly, I want to quit, right? So if the very first bytes don't match up, or the second or third, I don't want to go until the very end to find that out, right? I might as well just quit right away and tell my user that it's not a PDF. So I can say something like, this is not a PDF, new line, semicolon, and return 0. Okay. So let's make this again. Oh. Oh. Typo. All right, let's make this again. Make PDF. Okay, let's try running it. And I already pre-imported some test files. So I have test JPEG and test PDF right here. So I'm going to use test PDF. Okay, I don't get anything, and I would say that's a good sign. But if I try to do PDF test JPEG, it is telling me it's not a PDF. So seems like our algorithm is indeed working as we intended, and it is telling us if it's a PDF or not. I would argue it's also nice to know if it is a PDF. So if I get through my entire for loop and I don't quit, I know it is a PDF. So I can just return this message here. It is a PDF. New line. And then lastly, I want to close my file, right? So even though I'm not necessarily seeing any errors right now in the terminal, when I run this program, odds are something might come up later, but I just want to avoid that. So I'm just going to fclose the file that I opened earlier and also return 0 to tell the program that we're done. So let's make PDF again, and let me expand this. Let me clear this first. So make PDF. Okay, let's run PDF on test PDF. Okay, nice. And then let's run it again on test JPEG. This is not a PDF. Okay. Ooh, okay, this was a lot. So let's recap this one more time now with the code that we have. So let's actually go back to the line number 5 we actually never talked about, right? By defining this line, we are making sure that we can accept those command line arguments, right? This is our definition for doing that. Our next step is making sure that we have exactly the 2 command line arguments we were looking for. And you can go even like a little further, trying to figure out if they actually gave you a file name or something else. But this is pretty good for now. So I'm making sure that my user gives me 2 command line arguments, one for the program name and second for the file name. If it's not indeed 2, I want to return, I want to quit. I want to end my program and tell the user that they must provide me 1 file name. My next step is now opening this file, right? Like this is the equivalent of double-clicking on your file and opening it in Adobe or your web browser. And we're opening the file with the file name that the user gave us. So this is where the command line argument comes in, and we're grabbing that second command line argument at index 1 to use it as a file name to open our file. The second argument in the fopen function is quote unquote R, which stands for read, right? We just want to open that file, read information from it, not modifying anything, just reading it. So this will set us up to have that file opened. Next, I'm going to create the buffer for the file. And so we just talked about this new data type that is unsigned int. This gives us an option to have exactly 1 byte for each of those cells in our arrays, right? Like it's a buffer that is expecting 4 bytes. Our next step is creating the array of signature bytes, and I will give away what these hexadecimals are, but the 0x value that you see in the array are 4 hexadecimals, and 0x is telling us that they are hexadecimals. If you do some conversions, what they stand for is %PDF. So actually, there are these like hidden traces in the files that tell us exactly what they are. So really what we're doing here is something very simple. We're looking at the file sort of like on the micro level, literally looking at it byte by byte. And just by knowing this information from the internet, I know that the 4 bytes will look exactly like that. And so I can do something relatively fancy, right? Like, I don't know, if you try to open a PDF file with PowerPoint, right? Like, you won't be able to do that because it just doesn't support. Or maybe it does. Anyway, let me go back on that. If you try to open the file, right, with some program that like simply doesn't support that, one way that they can do that is like by simply checking the signature. And if it is exactly the file that they can't indeed support, they will return an error message, which is what we're doing in this program. Okay, so line 24 is where our like juicy stuff happens. So this is where we're reading those 4 bytes of information at a time, and we're using our new functions that we just learned. So as again, fread is structured in such a way that we want to read to buffer, we want to read 4 blocks of size byte, and we want to read it from input, right? So just some order and like algorithm to it, once again, that you need to get used to. And then our last piece, where is like our matching up is happening, is actually quite simple, right? Like we've seen the for loops before, we've done the if statements. It is just making sure that we're comparing this information correctly, right? We want to go one index at a time, comparing 1 cell at a time at each of our arrays. I can't do if signature equals buffer, like C just can't compare things like that. And if they're indeed not equal at any point, I want to make sure I'm telling A, my user about that, and B, that I'm quitting the program, right? If my very first byte doesn't match up between the 2 arrays, there is no reason to go all the way through, right? I want to make sure they just quit right away, tell my user, and end my program. But if I indeed got through the entire for loop and I didn't quit and I didn't tell my user something like that it's not a PDF, I can safely say that it was a success, that my file is indeed a PDF. And this is where some of the people might end this program, right? Like, I completed my goal. I either said that it was a PDF or that it wasn't. But an important step that we must take is closing the files that we opened, right? If you're coding the program similar to this, or like the one that uses fopen, literally just say, okay, I have one fopen here, I must have an fclose. And it is common practice to just do it in the end, but I could have also closed my finput on line 25 right here, because I technically am not using it further down in my program, but I kept it open just in case, like what if I want to access it again, but once I reach to the very, very end, like literally right before I'm returning and quitting the program, I just want to close the file to make sure I am not messing with any memory that I am not supposed to be messing with. Okay? All right. What questions do we have about this program, about pointers, memory, before we break for today? So someone said, could we use malloc for buffer? And we indeed can, right? We can use malloc to allocate the same amount of memory. In this case, like creating an array, just because I know exactly what size it needs to be, that works as well. Okay, let's see. Someone says, does fread remember the position where it stopped the last time? Yeah, so my pointer is sort of like moving every time I fread, and this is something that will be really helpful for recover, for example, right? Like every time you read some piece of information, your arrow just keeps moving forward and you're able to read the consequent one. So someone said, can we use char star argv? Yeah, we sure can. So this is sort of like would be taking our training wheels off, and we could do char star RGV. That is just the string, but I'll keep this just for now. Okay, let me see, there's so many questions. Can I point to a pointer? Yes, you can. I think someone already answered that in the chat. It'll just sort of be like creating this like string of things. There is no reason to do that unless you really need to, because pointers like take up space, right? When we use pointers, we're almost like doubling, if not more, the memory that we're using. So again, we want to use them exactly in the situations when we need to. So do fread and write only work in bytes? That's a good question. So actually, let me show an example. So if I go into manual pages, yeah, so let me show an example. If we go into manual pages and I open fread, I can read the description where under the size, and let me zoom in here a little bit. So under the size component, it says which is the size in bytes of the data, of type of data to read. So this is just how fread is set up, and you will actually find that the two, sort of like the size and the number, can be interchangeable depending on the situation. But yeah, we want to make sure we're specifying it in bytes, and the easiest way to go about it is just using the size off function, right? That will always return exactly the size of the data type that we're looking for. Okay, let's see. There's so many more questions. Can we close the file input inside the loop? Yeah, we sure can, but consider the case if we don't get to this part, right? If we try to close here, we might never, like if it is exactly in PDF, we might never reach that point. So you always want to make sure that you're closing the file, like not inside the if statements or like somewhere where your code might not reach, but just doing it in the very end is a good habit to get into. Okay. So the usage for the program, someone asked in the chat, is /pdf and then the name of the file. So in this case, I use test.pdf, and you just want to make sure you have those files in your environment before you try to access them, because obviously if you don't have it, you'll also get an error. Okay, let's see. So why do we return 0 when we already closed the file? So this is going back to the previous week, right, where we talked about the main function a little bit. So in my definition of the main function, I say int main and then whatever arguments I am accepting. By saying int main, I am specifying that the return type of my main function has to be like a number, an integer. So in this case, I am like returning 1 when I want to terminate on line 11 if I didn't in fact get the correct number of arguments. Or here, I am also returning 0 and returning 0 here. You could, again, write different numbers. It doesn't really matter. I could write 4, but 0 is for a successful program. And even if it's not a PDF, right, like our program was still successful. It identified what kind of file it is, or rather, if it was a PDF or not. So it was still a success. So we can return 0 here and then 0 in the very end. Alrighty. So let's go back to our slides. And again, this week and even the last week has been escalating really, really fast. So definitely make sure you're taking the time to go through the section slides, go through the recordings of the lecture, and even writing out things on paper and drawing those diagrams like we just did today would be really helpful. But this was it for today. My name is Yulia. This was week 4 of CS50. Thank you so much for joining our section, and I see you again later.